The holiday season is upon us, which means we are all racking our brains trying to think of the perfect gift idea. Why not give the gift of health information? At Panacea, you can access affordable whole exome sequencing. That's analyzing all of your coding genes, genetic counseling, and physician oversight in a 10-minute workflow for under $1,000. This is astounding when you compare that to the average whole exome sequencing price of $8,800 just last year in 2021. By knowing your hereditary risk for diseases like cancer and cardiovascular disease, you and your doctors can create a targeted approach to help catch the disease before it becomes a problem. Their launch is starting with the residents of Florida, so if you live in another state or a different country, you can sign up on their website to be notified when testing is available in your area. As a DNA Today listener, you get 30% off. That's a $300 discount. Just use code DNA Today at seekpanacea.com. Again, that's code DNA Today at SEEKPANACEA.com for $300 off. And to make it easy, the link's in the show notes. Make preventative healthcare a reality with Panacea. As a listener of DNA Today, you've probably heard me talk about NIPT, non-invasive prenatal screening or testing, that looks for extra or missing chromosome conditions during pregnancy. But did you know there's one that can also screen for recessive disorders like cystic fibrosis, sickle cell, and fetal antigens? Billion-to-One offers Unity screening, which does all of this from one blood draw from a pregnant person. Visit unityscreen.com for more information, and stay tuned for our upcoming episodes with Billion-to-One, exploring non-invasive prenatal screening for recessive conditions and red blood cell fetal antigens.
How is it that we find ourselves surrounded by such complexity, such elegance?
The genes of you and me, the genes of you and me, we're all made of DNA. We're all made of the same chemical DNA. We're all made of DNA. We're all made of the same.
Hi, you're listening to DNA Today, a podcast and radio show where we discover new advances in the world of genetics. From genetic technology like CRISPR to rare diseases to new research, we have you covered. For a decade, DNA Today has brought you the voices of leaders in genetics. I'm Ciitizen Deneen. I'm a certified genetic counselor and your host. Joining me to chat about SynGAP1 is patient advocate Mike Graglia and genetic counselor Elli Brimble. Thank you so much for coming on the show, and we're going to hear from both of your perspectives, which is really unique coming from the genetic counseling perspective and then the patient advocate dad aspect. So thank you both so much for coming on the show.
Thanks for having us.
So Mike, why don't we start out by you telling us about your son, Tony, and really how this whole journey started for your family.
Yeah, so Tony's a beautiful little boy, and SynGAP is a disease that takes years to really manifest, if that's the right word. So around 2, it was evident that Tony was a little slow, so people just thought he took after his dad, and we sent him to, speech therapy and occupational therapy and physical therapy. And his speech therapist just thought he was lazy, so they just drilled him. And one day he went to school, then he went to speech therapy, and then he went to physical therapy, and then he had a convulsive seizure. And that was how we knew there was a problem. So and we're very fortunate. We're close to Stanford. So we went right to the Lucille Packard Children's ER, and that began our journey with epilepsy and figuring out what was going on with Tony. And we went to another neurologist outside of Stanford who promptly did a chromosomal microarray, which is a great way to waste time and money. And that came back negative.
Yeah.
And this neurologist, who wasn't at Stanford, will remain nameless, was like, well, it's not genetic. And looking back, I realized how incredibly stupid that was. But
That's
luckily,
incredibly stupid. Oh my gosh.
Incredibly stupid. It was.
Wow.
I'm very comfortable saying that 4 years into the game. And luckily, we were multitasking, and we also got to see a genetic counselor at Stanford, whose name was Elli Brimble. And then, Elli, do you want to talk about what happened next?
Yeah, of course. So I had the pleasure of meeting Mike and his beautiful family. And, at the time I was really fortunate to be, building out a love and an expertise in epilepsy genetics. And so Tony in particular had a specific seizure type, and he presented much earlier than you would expect if this were sort of a run-of-the-mill idiopathic childhood epilepsy. And so going into it, we had a pretty strong suspicion that this was likely genetic, even if the technology today would not be able to achieve a diagnosis for the family. You know, it's kind of worth investigating further. So we ordered an epilepsy gene panel for Tony, and it came back with a number of variants of uncertain significance, as they tend to do.
Always.
But there was one in particular that we were pretty interested in, and it was an intronic SynGAP variant. But it was at -9, which, for those of you who are familiar with intronic variants, it's not really in one of the hot spots that would make us, you know, more likely to reclassify that uncertain finding as causative. And so this is where my like nerd hat hit in, which was that MNG had just released their clinical RNA sequencing test. And I was really looking for an opportunity to explore what that could do for variant interpretation, which, you know, Mike has become a champion of this, but variants of uncertain significance are challenging for families, they're challenging for providers, especially when there's really strong phenotypic overlap with that particular syndrome. So I reached out to MNG. You know, we had to do some prep work because, as Mike will probably get into, SynGAP1 is primarily expressed in the brain. So we had some concern that there would not be sufficient transcript in a blood sample or a saliva sample for this to be a reliable test. But they felt like there would be at least enough there for us to get some measurable read. And so we went through an arduous process of having a blood sample drawn during a hospital admission because we weren't totally sure how much it would cost, and, you know, didn't want Mike's family to be hit with a surprise bill. You know, all the genetic counselors on the call are going to understand all of the fun things we do to try to minimize the impact of a bill for genetic testing. So we ended up sending off the sample. There were only something like 32 reads that came back, but they did demonstrate alternative splicing as a result of this intronic variant. We were able to provide that clinical report to Invitae to have the variant reclassified as pathogenic. And since then, we've actually identified a number of other individuals with the same variant as well, 3.
Wow.
So that was cool, you know, from like a nerdy genetics perspective, but also, you know, really meaningful to maximize the technology and resources available to achieve a diagnosis for a family who, you know, ultimately, I think we can say it's been life-changing.
Yeah. So basically you ordering this and the panel that you did for epilepsy, for the, I don't want to say common, but the genes that we know to be associated with epilepsy in particularly children, you ordered that, and then you have to sift through all of these changes in Tony's DNA to say, okay, this is what could be causing it, and then narrow down on this one, you know, related to the SynGAP. Is it SynGAP1 gene? Or, okay, cool. And so with that, then figuring out, okay, looking at RNA analysis, which is newer. I don't want to say new, but it's newer.
Clinically, it's new. Been around for a while, but clinically,
yes,
definitely on the newer side.
That's a good way to phrase it. So when we look at RNA analysis, we're looking at genes actually being expressed. So it's really helpful, especially as you said, with an intronic. So the introns, for those trying to remember what they are, that's when we're looking at the part of the genome that's not actually expressed into proteins, but it helps kind of do like backstage work in genetics. So what is a common read? Because I've never actually ordered RNA analysis because I'm in prenatal, so that doesn't really come up as much. But what does that usually look at? You said there was 32 reads, and you said like that's not too much. Can you give me like a sense of like what's a typical amount that you might see?
I mean, I don't know for sure because I specialize in neurogenetics. So
I was going to say you probably don't order this a lot either.
I'm interested in aren't expressed in blood, but you know, typically when we're looking at next generation sequencing, we're talking about hundreds of reads. So, and reads just really refer to the number of times they were able to sequence a specific region of DNA. So, you know, 32 is not that much. If it had been much lower than that, there probably wouldn't have been enough confidence for the lab to report out on the finding.
Right. And so with this intronic change, and then you were able to say, well, we actually have a clinical case. We can back this up saying this is what actually is causing Tony's symptoms. Like, you're finding the root to it, which ends up being really helpful for other people that find this variant. And then they can say, well, there's evidence in other people. So that's a really important kind of concept in genetics and why data sharing is so important. So with that, how does this affect Tony in the sense of biochemical wise? Like, the three of us don't have this, so using us as examples, how does it work in us versus how is it not working in Tony?
So SynGAP1 is a haploinsufficiency, right? I think so I want to make two comments on what you just shared. The first is it wasn't that smooth on my end, and that was my fault. Like, when Elli came to me and was like, we need to do RNA sequencing, I was like, what are you talking about? Like, I've done a chromosome microarray, and then we did this epilepsy panel. Now you want to take my kid's blood again? Like, why? And now it might cost me what? Like, I was so dumb, and I was just like, why do you keep doing tests? When are we going to get an answer? And it was a testament to Elli's grace and kindness that she persuaded me that we should do this. And she was right. That was life-changing. And I think it was all now knowing what I know now. So, that was 4.5 years ago. As a result of that, my wife and I'm glossing over a lot of things, but, we started the SynGAP Research Fund. I've since quit my job. I run it full time as a volunteer. I spent my days and my nights working on SynGAP and talking to families. So I now know with confidence that at 8, Tony today really presents a lot of SynGAP phenotypes. But at 4, I'm still impressed that Elli and the team at Stanford were like, it could be SynGAP, because the presentation of the SynGAP is not like Dravet or some of these other terrible epileptic encephalopathies where the kid is seizing before 1 and you'd have to be an idiot to miss it, right? SynGAP, they're a little slow, and then they start with absence seizures and eyelid myoclonia, and then you get behaviors, and then the sleep gets disturbed, and then you get an autism diagnosis. So around 8, 9, 10, a SynGAPian is crystal clear. But around 4, 5, 6 is not very clear. But your question was about what's going on in the brain. So SynGAP as a class is presumed to be, it's always more complicated, but generally speaking, it's presumed to be a classic haploinsufficiency, right? So we have 2 copies of every gene. Everyone knows this. One of them has a typo. There are no homozygotes, right? If you knock out both copies in mouse dies. We haven't found any complete knockouts in nature. But if you have a typo, most of those when I was introduced to it, I was told all SynGAPians are hets. They have protein truncating, they have a good copy, they have a bad copy, boom, you're done. Now, fast forward 4 years, we have a natural history study with Ciitizen. I'll tell you, 3/4 of our patients are hets, and another quarter are missense and other exciting genetic stuff. But presumably, and the general dogma around SynGAP is it's a haploinsufficiency. So what's going on is Tony has half of the SynGAP he needs. SynGAP is the second most abundant protein in the postsynaptic density. So our synapses need SynGAP to work. It ties to DLG4. I won't go down that path. And as a result, learning, memory, sleep, intellectual disability, seizures, the full catastrophe, right? Like, the thing about SynGAP that's different than maybe better known diseases like Dravet is that the seizures take a long time to get severe in terms of a seizure, but the number of seizures, we think contribute significantly to the intellectual delay. Now, unlike another well-known disease, say Angelman, which is not a haploinsufficiency, separate conversation. Those Angelman kids are angels. SynGAPians, not so much. Like, the neurology paper on SynGAP from 2019 by Scheffer's group, author was Vlaskamp, 73% of those kids had severe behaviors. And then Andreas Jimenez's paper from the same year, 73% of those kids, the American cohort, had autism diagnoses. So the SynGAPians, at the molecular level, are haploinsufficient, but in real life, the seizures take time to present in most, not all cases, but the behaviors get pretty clear pretty fast. Elli, what would you correct me on any of that?
Can you explain a little bit more about either using Tony's example or just speaking generally about, as you call them, SynGAPians?
It's going to be hard for me not to get riled up talking about SynGAPian behavior. So here's the deal. Our kids don't feel pain. Our kids don't have fear. And our kids perseverate. And what I say to everybody at school and every therapist is no is not going to work. I don't care if Tony's running off a cliff. Saying no is just going to make him run faster. So you got to redirect him. And if Tony gets mad, so they perseverate, they'll push like crazy, and then when they get mad, they are dangerous to themselves and others, right? They bite, they kick, they're strong. They have low tone, but they're strong. It's very confusing. And an aggressive SynGAPian is a little bit scary. And as a dad, I mean, Tony's 8. He's 80 pounds. I'm, older, 200-ish pounds. I can kind of contain Tony. But in a couple of years, I don't have a chance. So, that's when we start talking to families about, every parent, when you get an epilepsy diagnosis, like, I don't want to over-medicate my kid. I was one of those. But now I'm at the point where I talk about appropriate level of medication, right? We have to treat the seizures, we have to treat the behaviors, we have to treat the anxiety, we have to treat the sleep. Because if you don't treat, our kid is missing a very important neuroprotein. And in the absence of that, they're a hot mess. And guess what? The family suffers. Like if your kid's not sleep, the other big, I think the big things about SynGAP are sleep and behaviors. So we talked about behaviors. Our kids don't sleep. They will not go down without melatonin, and they will not stay down without some other intervention. And a family that hasn't slept for years isn't in good shape.
Yeah, that's really tough on your health, physically, mentally, and just watching your YouTube channel and learning more about your family. At least at the time, like 4 years ago when Tony was around you said that he would wake up like the same time every night. Is that still true today?
No. I mean, now he gets, we put him down with melatonin and we keep him down with guanfacine. Guanfacine has been really effective. He's also on some anti-seizure medication. And we know from some studies that SynGAPians, and this is true of a lot of DEs, but SynGAPians especially have a cluster of seizures at the sleep-wake and wake-sleep transitions. And they tend to have more seizures when they're sleeping than when they're awake. So when a family calls me and says, it is so weird, this child gets up at 4:34, 2:37, or whatever time it is, every single night, I'm like, your kid's having seizures, go get an EEG. And it's, I'm not a doctor, I'm not giving medical advice, which I'm always sending people back to their neurologists. And I'm like, get an EEG. As they get older, the seizures progress. I don't know, Ellie, would you add to that?
Yeah, I mean, one question I always think of when families share their experiences, and especially someone like you, Mike, who's so well plugged into the community, when you talk to families about SynGAP, what are the things that they say are most impactful for them? What are some of the things that they are hoping to see the most change or improvement in with some of the work that you're funding?
So they all want their kids to be verbal. Our kids are very complicated. They can understand more than they can express. And for the kids who are super low verbal, the parents have no idea what's going on. And because of Tony's strange mutation, for the geeks on the call, so this is actually one of the ways the fund started. We went to one doctor who was ostensibly a SynGAP expert, and he looked at Tony and he's like, this kid is so high functioning, because he was verbal, said he can't be haploinsufficient. He just can't. And because because I don't believe he's haploinsufficient, I don't believe that we're going to give him ASOs. Because with the classic neurohaploinsufficiency, like we're seeing with Stoke and Dravet today, and like we hope to see with SynGAP and other companies, including Stoke tomorrow, you don't do a genetic therapy to fix every mutation, right? Instead, you say, well, they're haploinsufficient, so let's just make the good copy work harder with an ASO, and then we'll help all the kids. The doctor said the trouble with Tony is if he's not really haploinsufficient, if the bad copy's doing something, and we upregulate all the SynGAP, we might push him above 100%. Guess what? We can't find over 100%. So no one's going to want to dose your kid. So that sort of freaked us out. And we said, oh no, we have to study Tony. And that was one of the questions we set out to answer is like, maybe, is he more than fit? And now we know, this is where it gets geeky, based on the animal model built on that mutation, those models are haploinsufficient, but the isoform balance is different, right? So SynGAP has different versions, different I don't know how to describe an isoform, Ellie can. And so it looks like Tony has 50% of the expected amount of protein, the mix of that protein is high in a very desirable isoform, the alpha-1. And that seems to be why he's the way he is. And but to the question that was asked was, what do parents want? They want to understand what's going on in their kid's head. And since Tony is verbal, I agree with them because he comes up with the craziest things. I'm like, there's no way I would ever have guessed that was what you were mad about something I said 2 days ago. Like, you want this thing that we just, what? Like, so I think the first thing people want is to understand what's going on with their loved one. The second thing they want is the seizures to go away. Third thing they want is behaviors to be more normal. But I think the behaviors are really just frustration because our kids are so misunderstood. And then the other thing where I thought you were going with this, Ellie, is GI. Parents call me and they're asking about seizures and behaviors. And I say, when was the last time your kid pooped? And they're like, what are you talking about? And I was like, well, if your kid hasn't pooped in 3 days, first of all, if you hadn't pooped in 3 days, you'd be in a bad mood. But second of all, our kids, and this is true of a lot of kids with epileptic encephalopathies, our kids have severe GI issues. And that's another area where you need an intervention, everything, all the different ways you can make a kid poop. And when they get backed up, the seizures get worse and the behaviors get worse. So people call it asking me expecting me to say something profound, which is obviously not going to happen. And then I'm just telling them, go get some fiber gummies. What? But fiber gummies and 5-HTP is where I send them.
And you have to look at the whole person. I think that's such a great example of, like, we can't just treat symptom by symptom. You have to look at the constellation of symptoms and say, okay, how are they affecting each other? Non-invasive prenatal testing screening has been around for a decade now, as long as DNA Today, and the technology has evolved in those 10 years. The screening started to detect Down syndrome, and now Billion-to-One's Unity screen assesses for the chance for pregnancies to have aneuploidies, which are extra or missing chromosome conditions, recessive conditions like cystic fibrosis and sickle cell, and the presence of red blood cell fetal antigens. Billion-to-One named the screening Unity Screen as it brings together fetal screening for aneuploidies and recessive conditions, and it represents uniting pregnant patients in more equitable care. Unity does not require a blood sample from the other biological parent or sperm donor to assess fetal risk. This enables more pregnancies at risk to be affected with recessive conditions to be identified early in pregnancy as compared to traditional carrier screening. Billion-to-One is working towards one goal: to detect disease one molecule at a time. Know early with one simple blood test. Visit unityscreen.com for more information. And stay tuned for our upcoming episodes with Billion-to-One, exploring non-invasive prenatal screening for recessive conditions and red blood cell fetal antigens. As a listener of DNA Today, you've heard me interview countless guests about genetic testing. I'm sure you've thought to yourself, I wonder what my results would be. Now you can find out or gift it to someone else for the holidays. At Panacea, you can access affordable whole exome sequencing. That's analyzing all of your coding genes, genetic counseling, and physician oversight in a 10-minute workflow for under $1,000. As a DNA Today listener, you get 30% off. That's a $300 discount. Just use code DNA Today at seekpanacea.com. Again, that's code DNA Today at SEEKPANACEA.com for $300 off your kit. The link is also in the show notes. Do you like listening to podcasts that help you get centered and reframe your mindset? Check out All Things Therapy. The show focuses on the concept that we can change our consciousness one conversation at a time. Most episodes are about the same length as ours, about a half hour, and feature an engaging guest. You can stream on all major podcast players by searching All Things Therapy. You started a research organization so that we could start answering some of these questions. And, you mentioned mouse models, so you've already got that going. What else do you have in the pipeline in terms of treatment? I mean, you mentioned ASO, which you might have to define for some people listening. But what's the status? Is CRISPR on your radar to possibly, quote unquote, fix the typo in the genome? What's your current status with research?
So we started thinking we had to fund an ASO. And then a year after we started, Stoke announced their ASO work on Dravet. And then a year ago, Stoke announced they were also working on SynGAP, right? So when we started, the very first grant we gave was to Dr. Hugh Ganir at Johns Hopkins, the guy who identified the gene in 1998, to develop an ASO. And with a haploinsufficiency, if you can use an antisense oligo to take, because an ASO is I think of them as little assassins, right? They go and they break something. So if you can go and take something out, take out some regulator of SynGAP expression and make the wild type copy make more,
So
you
take
win,
the brake
right?
off, right? The
Cut the
assassin
brakes.
takes the brake
Cut
off.
the brakes.
Yep, cut the brake.
And then make the good copy make more. That's broadly speaking. And that remains something that I'm hanging my hat on, because gene therapy, I know I have friends, we have friends who have children who have both copies mutated, right? Some of these diseases, they have no choice but to do gene therapy. But we have a good copy about a gene that we barely understand. We don't fully understand. So let's just go ahead and make the good copy work harder instead of pretending we know which isoform to put in, right? So base editing, all this fancy stuff, sure. You know, if David Liu wants a mouse, we're actually making him a humanized mouse right now in the hopes that he will think about it. But that's 5 to 10 years out, if I'm optimistic. I think what's 3 to 5 years out is an ASO. And so there are Stoke and Praxis have both announced they're working on an ASO for SynGAP. Dr. Ben Prosser at UPenn is working on an ASO for SynGAP and publicly working with Ionis. So there's 3 good companies who are already talking about ASO. And if God is kind, maybe there'll be more companies who announce soon. Who knows? But for now, like, I'm focused on going after the root cause. Let's do an ASO. And then the other thing that SRF is there's 2 other things we're investing in. One of them is small molecule repurposing. While there are researchers doing that, researchers don't always move at a speed that is acceptable to or makes sense for families. So we're investing in a small molecule repurposing thing. And then the other thing is, since I do have Stoke and Praxis and Ionis and hopefully others working on SynGAP, I've stopped saying, okay, we need to make an ASO. And I've started saying, what are they going to measure in clinical trials? And this is, I think, one of the most important things that I should be obsessed with, because I don't know, Ellie, do you want to explain this better, like biomarkers and how hard it's going to be to measure seizures with SynGAP? Because I think that's a really important topic that you should talk about because you're smart.
So, you know, one of the things that I spend a lot of time talking about now in my current life, and is where Mike and my paths have continued to cross over, is around this concept of clinical trial readiness. And so there is a strong emphasis, and rightfully so, on funding and identifying candidate therapies to target the source of a patient's symptoms. And, you know, we're in the land of genetics, so often those are gene-based therapies. But one of the challenge for these rare disorders is that by definition they're rare, and so they may be less well understood than more common conditions. The spectrum of those disorders may not be well characterized. And, you know, these are distributed populations, so any one physician or clinician may, you know, consider themselves an expert because they've seen, you know, 6 to 10 different patients with those conditions, right? So one thing we've spent a lot of time thinking about is how can we help accelerate clinical trial readiness in the rare disease community, so that at the same time that we are identifying these candidate and very promising therapies, when those are ready to hit a trial, we will have understood that condition well enough that we can identify or propose a set of endpoints that may be reasonable to measure to demonstrate efficacy of that therapy. We know that one of the main reasons that drugs fail in clinical trials is not because they don't target the right thing or have the right effect, but because we weren't effectively measuring the impact of that drug. So, you know, this is really what Mike is describing, is as SRF is funding work to identify, you know, an ASO or another molecule that might be effective, can we also position the community so that we are ready to go into a phase 1-2, and we know what we are going to measure, and we have confidence that the thing that we're measuring is meaningful to families as well.
And I imagine that's why the SynGAP Research Fund, which you guys have been saying SRF, has partnered with Ciitizen to launch your natural history study. Why is it so important to have a natural history study? What are you hoping to document from this so that when you do go into clinical trials, you have this baseline evidence?
Let me give a short answer to that, and Ellie will give a better answer. So first thing, what Ellie just said, right? We want to gather as much data as we can to see if we can better understand the natural history of the disease. I've only counted 1,200 patients worldwide, about a third of them in the U.S., right? Of the less than 400 patients in the U.S., we've got almost 200 of them in Ciitizen, right? So that's That's a good chunk of data that Elli and her robots and her team have gone through and tried to extract everything that's useful. But on top of that, if we don't do that now, and I've made this case repeatedly in my podcast, and I wrote a blog called 1 Year Sooner, where I pointed at Dravet, and Stoke showed up to work on Dravet. They looked at the natural history data, and they're like, "This isn't good enough," and they launched an observational study called, I think it was called Butterfly. It's cool. All their trial names are named after different butterflies, but their observational trial is called Butterfly, where they just studied Dravet for you to figure out what they were going to measure. And I was like, oh my God, they've got something that works. They're curing mice of Dravet, but they don't know what to measure, so they're doing their own. Like, that's crazy. At least we can get the natural history study started so that when they're ready to dose humans, they're not waiting for we know as much as we need to know. And then the other thing I'll add that we're hoping to fund, we got one grant in on this, and I want to do another one next year, is look for surrogate biomarkers, specifically in EEG readings, right? So the fantasy here is, and this is kind of cool, this is sort of genetic counselors and neurophysiologists run into each other. What if we could pull EEGs, take genotype, EEG reading, and find gene-specific EEG signatures? And what if?
Yeah, you just blew my mind a little bit. Wow.
Blows mine every day. I dream about this stuff. Because first, we could then have a signal that changes. Like if you put a drug in Tony and his brain starts making more SynGAP, what are we going to measure? Is he going to poop faster? Is he going to seize a little bit less, although we can't really seize EEG? I mean, it's really hard to measure progress in these kids in a time frame that makes sense for a clinical trial. So if we had an EEG biosignal, that would be huge, number one. Number two, and this is where I really go sci-fi. What if we do find a biosignature, an EEG tracing that is specific to Dravet, SynGAP, SCN2A, pick your favorite gene, right? Just making stuff up. Wouldn't it be amazing to put that in the EEG software that's in every hospital in America? And then your neurologists and your neurophysiologists, they don't have to be trained in genetics. The little robots could just be like, bing, bing, bing. Test this patient for SynGAP1.
Right. Confirm, not even like, test for something. Confirm this diagnosis. I don't know. You might want to patent that. I don't know if we should put this out publicly. You should patent it first. Like that.
There are people who have patented it, and I don't want to make any money. I do not want. People keep asking me if I want to do stuff. I'm like, I don't want to make any money.
But
I
then
just want a
free
drug
access,
for my kid.
Right? Get the patent so other people can't, so that you can open it.
I didn't come up with this.
Yeah.
I'm typing from. I'm cribbing off other people's homework here. But I just want them to move fast and to use platforms like Ciitizen to get those EEGs, do this analysis, and figure out if there's a there. Because I'm not worried about there being a medicine for Tony. I'm worried about the clinical trials taking too long or not being done as well as they could be, and not being able to give that medicine to Tony.
Right, of needing FDA approval. If they can't show that the data is really effective, then the FDA is not going to be like, oh yeah, sounds good, start prescribing it to patients. So yeah, I can see where that data is really important. Then you're like, how are we going to get the data? That's a really interesting perspective. And as you mentioned, Mike, you host a podcast, SynGAP1, so you kind of take 10 minutes and you update people. It's on a weekly basis, right?
It's sort of on a weekly basis, and it's sort of 10 minutes. Like all the rules about podcasts, be regular, be consistent, be on time, high production value. I do none of that. Like it's me and a camera, and I'm like, this is what you need to know. And I do it every week. It's very
and you bring so much energy to it. I was just listening to your latest one where you talked about that you were going to Atlanta for a gala.
Right.
And meeting up with other people in the SynGAPian community there. And I mean, you bring so much energy to it. You're so excited about the science and the data. And I definitely recommend for people to tune in and just, to also keep up with what's going on with research, because there's a lot happening. Like way more than I thought when we first connected. I was like, okay, they're probably trying to figure out natural history study or something. But it's like, oh, you've already got mouse models. You've already got companies working on this. Like it's really exciting.
Yeah, and
we started with Elli.
I want to make a quick plug that, Mike is exceptional. His progress has been extraordinary. And I think most importantly is he is putting it out there so that no other family has to try to figure it out by themselves like, they had to do 4 years ago. So take advantage of that podcast. It's a great resource.
Yeah, don't have to do all your own research. Just listen to what Mike has been researching and diving into, and he's keeping up with everything. Thank you both so much for coming on the show. I mean, this was just so enlightening just to dive into, and so cool to have both of your perspectives. Elli coming from the genetic counselor side that actually diagnosed Tony, and then Mike, obviously being his dad, patient advocate. You're doing this day in, day night. So, thank you so much for all your hard work. I think, Elli and I would both agree that the patient advocates are really the backbone of our community, because you guys are educating us on so much. And I feel like you guys don't get enough credit, because people are like, oh, well, this person has a master's in genetics. I'm like, Mike, I don't know if you do have a master's in genetics. I think you're more business background. But to me, yeah, you know way more about this than I do, right? So just want to really thank you so much for, keeping people in your own community updated, educating us healthcare providers, and the rare disease community in general. So thank you both so much for taking the time and educating my audience.
Thank you.
Thanks for having us.
For more information about today's episode, visit dnapodcast.com, where you can also stream all episodes of the show. We encourage your questions, comments, guest pitches, and ideas. Send them all into info@dnapodcast.com. Search DNA Today on Twitter, Instagram, YouTube, Facebook, so you can connect with us there. And a favor, please rate and review the podcast on Apple, Spotify, or wherever you listen. This truly helps us climb the charts and allow more genetic nerds like yourself to find the show. DNA Today is hosted and produced by myself, Keir Deneen. Our social media lead is Corinne Merlino. Our video lead is Amanda Andrioli. Thanks for listening, and join us next time to discover new advances in the world of genetics.
The genes of you and me, the genes of you and we're all made of DNA. We're all made of the same chemical DNA. We're all made